Hello, everybody. Good morning. I hope you're all enjoying the conference and enjoying some of the interesting discussions that people are having. I know I certainly have been as well, and I hope that you all find this one just as interesting. Today we'll be discussing orchestration as code and how you can make the most of your orchestration capabilities using a combination of DBT Cloud and Snowflake. My name is Rafael Cohn-Gruenwald. I'm a data engineer at Bernstein at AB, which is a company that works in the financial services sector. At AB, our data team has been on quite the journey, starting off with Informatica and Oracle, legacy SQL code that's 20 years old, migrating it over to DBT and DBT Cloud, sitting on top of Snowflake, a journey that I think probably many of you in this room have been on. And over the course of that journey, you encounter many problems. We solved some of them. You guys have solved some of them. But one of the problems that we came across that proved most persnickety for us was how we handle data warehouse rebuilds when we're dependent on data that's mission critical but arrives irregularly or inconsistently. So in our case, this is our profit and loss data, which, as you can imagine, for a company that works in the financial services sector, is probably the most important data set that we produce. It's really important in particular because it's used both by our compliance and risk teams for reporting and portfolio evaluation, and it's also used day to day by our traders for continual position evaluation. Essentially, it's what we use amongst many other things to make a profit. For us in particular, our asset manager provides us with updates to our portfolio throughout the day. But critically, there's not an SLA in place that actually dictates when we can expect to receive that data. In practice, what that looks like is many syncs of data throughout the course of the day, some of which is a refresh of our entire book. Sometimes it's just segments of our portfolio. But I'm going to zoom back out for a sec. This is a problem that I think spans many different industries, and this is what I'm hoping to talk about, is a situation where you're dependent on mission-critical data that arrives inconsistently. And the question that we sought to solve was how we could rebuild our data warehouse in an easy and efficient way while accounting for that. So the first solution that we looked at, the one that's most obvious, is to use just a series of scheduled rebuilds. Something like rebuilding your job on a 2-hour basis or a 4-hour basis. In DBT Cloud, this is really easy to configure. You just go into your job settings and you pick whatever cadence you want. The problem is that for this particular use case, it's not really a viable solution for two main reasons. The first is that it's really compute inefficient. If you don't know when your data is going to arrive and you're refreshing, say, every 4 hours, there's going to be a 4-hour period where you don't get data, but you rebuild anyways. Essentially, you've just burnt compute credits because you're just rebuilding your models to produce the exact same insights sitting on top of the exact same data. The other thing is that there's the timing difficulties associated with irregular data. Say, for example, you rebuild your models, and then immediately after that, you get data. Well, you'll be serving stale data to your business users for the next 4 hours until you rebuild. What I have up here on the chart is all of our sync times for our positions data over the course of the entire month of June. And I just have this here to really emphasize the variability. You'll notice some gray lines that are bisecting each day. Those are 4-hour blocks of time, just for emphasis. But take a look at the blue box at the top of that chart, which is comparing June 3rd and June 4th. You'll see that on June 3rd, we had 2 syncs over the course of the day, whereas on June 4th, we actually had 5 syncs, 4 in the morning, 1 very, very late in the evening. You can't really plan for that type of syncing. Same thing with the red box, which is comparing the first sync of the day across June 3rd, 10th, 17th, and the 24th, all of which were Mondays. In our case, the first sync of the day is arguably the most important because it provides the freshest data for the day. But when you have variability, say on June 3rd, the sync occurring just after 8 a.m., but on June 17th, the sync occurring around 5 a.m., again, it's really hard to schedule rebuilds when you have that type of variability. And then you'll notice that there's these green boxes throughout the chart. This was a nice to have when we were thinking about this. We get syncs pretty late into the evening, and honestly, most people aren't looking at their data late into the evening. So we're sort of asking the question of, why would we even want to rebuild at 7 p.m. or 8 p.m. in the evening if nobody's going to be looking at it, and the next morning we're going to rebuild anyways, and the data is going to get caught up then. So that was something we just kept in mind when we were looking at possible solutions for this. The next solution that we actually were using for a while is almost the polar opposite, which is just manually triggering our jobs based on when we actually receive data as notified by the business users. So I've gone through and I've sorted back through our Slack and ID'd a couple of messages where we had our business users actually asking us to trigger our jobs. What would happen is that the asset manager would eventually provide them with an email saying that new data had been provided, and they would come and ask us to trigger the jobs. On the bright side, this is insanely compute efficient. We're literally only building exactly when the business needs us to. And the other thing is that it effectively accounts for the time variances because, logically speaking, we know that the data that's relevant has already arrived. But this is just a terrible user experience for everybody involved. It's not the job of the business users to be telling us when we need to be kicking off our jobs. And honestly, it's not the jobs of analytics engineers or data engineers to be kicking off jobs as part of their day-to-day process manually anyways. Really, what we want is a way to dynamically detect the new data and automatically trigger a load. Now, this is a problem that I think has been around for many, many, many years. People have solved it many times over. But when we were looking at this, we came across an interesting solution for our use case that we thought would be worth sharing, which is why I'm here today. But essentially, here's our situation. We have our data provider that's providing us our raw data on some random schedule, essentially, into our raw database in Snowflake. And then we want some sort of process that can look into that raw database and trigger our dbt Cloud job. And what we realized that we thought was pretty powerful was that this was entirely accomplishable directly within Snowflake itself without the need for any other sort of third-party tools. And by making use of Snowflake's streams, tasks, and Python stored procedures, along with a couple of other resources as well, we were able to accomplish exactly that. So in case you're not familiar, I'm going to walk us through the key resources that we'll need, and then I'm going to show us some pseudocode and walk through that as well, so that you guys have an understanding of how this all works. But I'm going to start off with Snowflake streams. Streams are resources in Snowflake that effectively track any sort of DML changes that are made to a table. The way they work under the hood, and this is going to get a little bit technical just for a second, is that Snowflake effectively stores data as column-oriented files similar to Parquet files in the blob storage of their cloud provider of choice. And they append new files when DML changes are made. So streams essentially are a point-in-time offset that track when new files have been added to the blob storage. What that means is that they're really, really efficient because all they do is just look at a point in time and see if anything has changed after then. And to make our lives even easier, we don't have to worry about any of that technical stuff. Snowflake actually provides us with a really helpful system function, which is the stream has data function. All this does is return a Boolean value indicating whether or not DML changes have been made to a table after the stream has been created. The next piece of our solution is tasks. For those of you who are not familiar, tasks are essentially exactly what they sound like they are. They're UDFs that you can basically use to execute procedural logic or call a stored procedure, but critically, they're configurable to run on a specified cadence, and you can configure them to run on any sort of condition as long as it evaluates to a Boolean. So using the stream has data function in combination with the condition effectively gives us a way to trigger only when new data has arrived in the table we want to track. And then using the task, we can trigger a stored procedure. Now in Snowflake, stored procedures are really powerful because you can write stored procedures in Python and have them execute in Python. What that means is that you can take advantage of any Python library that you want, including the requests library. So in conjunction with network rules and external access integrations, what you can actually do is write a Python stored procedure directly in Snowflake and have it trigger any API that you want. So in our case, we essentially strung together our streams and our tasks to create a trigger and then use it to call our Snowflake stored procedure that hits the dbt Cloud API whenever we want it to. This is the pseudocode to make that happen. I'm going to walk us through it. So on the top left here is step 1, which is the configuration of the network resources that we need to make this happen. Starting off with a network rule. Essentially, all we're doing here is we're specifying that we want to allow access to the dbt Cloud API domain, which in this case is cloud.getdbt.com. We also have to specify that it's egress because the request itself is coming from within Snowflake outside to dbt. Now, network rules on their own just specify essentially a way to access some sort of external resource. You have to bundle them inside of external access integrations, which we're doing on lines 6 through 8 in that first box. The external access integrations can be combined with other resources in Snowflake and then allow them to take advantage of those access integrations when they're attempting to do something, which is what we're doing in step 2 in our create procedure step. So this is the real meat of it. Essentially what we have here is a Python stored procedure. On line 7, it's taking use of the external access integration that we defined in step 1. The other thing, there are a couple of other things to note here. First of all, this is entirely Python that's being executed. And you'll see that on line 23, we're assembling the URL that we're going to hit, which is in our case, the job run API endpoint of the dbt Cloud API. We're also specifying a job ID input parameter in the procedure itself. That just makes this a little bit more configurable. We can reuse the same procedure for multiple job invocations if we want to. And then lastly, on lines 17 and 18, for brevity, I've hard-coded the access token and the account ID. I do not recommend that you actually do this in practice. Instead, what you can do is use a Snowflake secret and access that from within the Python itself. I'll be providing source code at the end of this that actually does that, so you can reference that as well. And then lastly, we have to knit it all together in step 3, which is the orchestration piece. Setting up the stream itself is very simple. All you have to do is specify the table that you want to track and then create the stream on it. And then we set up our task. In this pseudocode, for example, I have it running on a 15-minute basis. And critically on line 6, we're checking the stream has data system function for the stream itself. So if no data has been modified in the underlying table, the task will not execute the following SQL on lines 9 through 14. If there is data, though, it will execute. And there's a couple key things to note here. The way that streams work, like I mentioned before, is that they utilize a point-in-time offset where essentially any new data changes would be caught up in that in the stream. But we don't want to re-trigger off of the same data multiple times. So you have to reset the stream following a trigger. And that's exactly what we're doing on line 10 and 11, on lines 10 and 11. The way that you clear out a stream, essentially, is you use the results, the data in the stream itself in a DML operation. But in this case, we're not interested in what is in the stream. All we're interested in is if the stream itself has data. So we're taking the data from the stream, inserting it into a temporary table, and it's going to be gone following the task invocation. And then lastly, on line 13, we're calling our stored procedure. And the awesome thing is that that's really all it takes for this to work. So we've been running this in production since February or March. And as you can see here, this is just a screenshot of our job runs for one of our jobs that we're using this for. And I think the fun thing to note here really is the actual trigger times of all of these invocations. 8:19 a.m., 12:42 p.m., 6:42 a.m., just really emphasizing the variable nature of when we're receiving our data, and we're building as quickly as possible, pushing it out to the business as quickly as possible. So that's a really cool solution, but there's some major drawbacks with how I just talked about that. First of all being, essentially that pseudocode that I showed, initially, all I did is I just wrote it in my own Snowsite worksheet, which is extremely problematic to use in a production environment. Great for testing, though. So there's no version control, and there's no change management process around those resources as I defined them just in my Snowsite UI. And then the resources themselves are not very durable. Stuff gets deleted all the time by accident. Maybe a production schema gets dropped, Or maybe your task goes into a suspended state and you don't notice. And then lastly, there's not a lot of visibility into the overall process. If I'm out and something gets deleted, nobody else has access to my Snowsite UI worksheet, right? Unless I specifically shared it with them. And even then, it's not really, you shouldn't be deploying off of a worksheet like that. But what we can do actually is we can extend the capabilities of dbt Cloud and address all of these issues. So what we realized is that, like dbt models, the orchestration resources that we were using should also be encoded for durability and consistency's sake. And the beauty of dbt Cloud and Jinja is that we can actually use them in combination as our IAC deployment software. So if any of you all are familiar with how Terraform works, this is the exact same concept. What we did is we wrote a series of resource macros that would define Snowflake SQL resource definitions that could then be used repeatedly over and over again to instantiate resources as we need them. We then built a series of deployment macros that did exactly that. They would call the resource macros for specific cases. If we wanted to create a stream, all we have to do is pass in the table we want to track. If we want to create a task, all we have to do is provide the necessary parameters. And then, to resolve the issues of durability, we can actually use dbt Cloud to run our deployment macros on a periodic basis in the event that things get deleted or tasks get suspended. Here's an example of one of the resource macros. All this macro does is creates a stream given a database schema in a table. The real meat of the code here is on lines 14 through 19. Essentially what we're doing is we're preparing our Snowflake SQL statement to create the stream, and then on line 19, we're actually passing that statement itself to Snowflake so that an invocation of this macro results in the creation of a stream tracking the specified table in Snowflake. Likewise, here's a macro, a resource macro for the creation of a task. It's a little bit more complicated, but ultimately the output is the same. An invocation of this task macro results in the creation of a task itself in Snowflake. Now, as we were developing this, what we realized is that sometimes you have dbt Cloud jobs that are maybe dependent on multiple tables instead of a single table. Or if you want data, new data in one table or another table, but they both trigger the same job essentially. So we modified the task a little bit to accept a list of streams. And then what we're doing on lines 6 through 17 is we're iterating through the list of streams and essentially preparing them and then joining them together using an OR operator to create a more complex when condition in the task so that if any of the tables that we want to be dependent on have new data in them, they will act as a trigger. You could modify this if you have a requirement where you want all of the tables, you would use an AND operator. But essentially, this is highly configurable. But the key output is that an invocation of this macro results in the creation of a task directly in Snowflake. Here's us stringing everything together. On the top left side, we have our deployment macro to create the stream itself on the positions data. So as you can see, we're just calling our stream resource macro. And on the top right side, we have our deployment macro for the task itself, where we're passing in this case, a list of one of the stream that we want to track. Now, we could invoke each of those macros on our own from the dbt Cloud CLI, but really, it doesn't make sense to do that. So what we did is we actually encapsulated them together in this build orchestration resources macro. And an invocation of that macro itself runs and builds every single resource that we need for orchestration all in one go. And as you can see, that can be run from the dbt Cloud CLI as well. Or it can be configured as a dbt Cloud job and set up to run on a periodic basis. In our case, we do it every Saturday. So now I'm going to shift gears a little bit and do something scary. I'm going to do a live demo and talk a little bit more about Python procedures in Snowflake. So right here we have some dummy order data that I mocked together. The actual data itself doesn't matter. The point is that when new data is inserted into the table, something happens. But before we do that, I just want to show you guys what a stream looks like. So in the background, I deployed the stream and task and procedure resources using those macros. So this is the stream that is currently tracking that table. As you can see, there's nothing in it because it's been reset and no changes have been made. And this is the stream has data macro or system function, which returns false right now. But what I'm going to do now is I'm going to insert into this table. One row inserted. And as you can see, the system function now returns true. So in the background, that task is going to run in some number of seconds. The when condition is going to trigger, and it's going to kick off our dbt Cloud job. Before we prove that out, I just want to talk about two other features that you can use with the Python stored procedures. One of the main drawbacks of the Python stored procedures right now is that there's not really effective logging capabilities in them. You know, any good data engineer knows that you want to have as many logs as possible, really, to diagnose what went wrong in the event that things go wrong. In this case, any sort of logging statements that you make just poof off into nothing. You can't actually see them. So the workaround that we came up for with this was to create a list in our Python stored procedure, and any time that we wanted to log something, instead what we did is we just appended our log to the list, and then at the end of the procedure, return the list. So in practice, what that looks like in our task is something more like this, where we're calling the dbt Cloud run job procedure, and then we have one more SQL statement right here. And we are using the last query ID to get the results, which in this case are our orchestration logs, and then we're inserting them into this orchestration logs table, which I will show you now. And so we can see that just a few minutes ago, we inserted one new row into this table, and it has the logs from our procedure run. The other thing I wanted to talk about with the Python stored procedures is that because they're in Python, they're highly configurable. So I want to call back to what I mentioned pretty early on in the talk, which was around we don't really want to trigger our jobs after 6 p.m. So we actually customized the Python logic and our procedure logic to allow for us to specify bounds for when we want to kick off. A minimum start time, a maximum start time, specified days of the week. And so we can specify those when we're invoking our procedure, and we actually have a series of tests in the Python that will take the current time and verify whether or not it should actually trigger the job. And that essentially, that series of tests is run every time the stored procedure is invoked, and the outputs, if it's within the accepted bounds, it'll trigger the dbt Cloud job, otherwise it will not. Those outputs are then put into the logs, and we're able to diagnose if something went wrong. But coming back over here to our example job, what we can see is that 2 minutes and 17 seconds ago, we had our job that was triggered, kicked off via a Snowflake task from the insert that statement that I just ran. So as I mentioned, I'm making all of the macros that we use available for use. Feel free to check it out. And I'm happy to answer any questions right now, or feel free to connect with me on LinkedIn and ask any questions then. But thank you all for listening, and I'm happy to take any questions. Yeah?
Thanks. It's a great presentation. Question around your route going towards streams and... Thanks. So question around your approach towards Snowflake streams and tasks to get the new data. Have you evaluated dynamic tables with not a lag which is default, but I think now they have like a range where they can say, they can produce the updated data based on what is good for the compute. So
so essentially the question is, why did we choose this approach as opposed to dynamic tables, which effectively accomplish the same thing? And the answer is two-part. When we built this, we didn't actually have access to dynamic tables in Snowflake. But the other thing is that the job in particular that we were looking to kick off, the DAG itself consists of, I think, close to 70 models. And it would have been a lot of refactoring in dbt to actually make those all dynamic tables. We just didn't feel like it was worth it. So our solution here is kind of an on-the-fly solution that we can deploy when we have those use cases where we want to kick stuff off dynamically. But like I said, this is a problem that's been solved many times before. This is just one solution. Dynamic tables is also a very viable solution. Yeah, thank you. Any other questions? Yeah.
Hello. Yes, my question is also about a possible alternative that I'm curious if you thought about the trade-offs of. So the freshness feature in dbt and conditional builds based on freshness.
Yeah, we've explored the source freshness feature, and I'm having trouble. So our journey for this was a lot more complicated than what I've described here, and there was a point in it where we were looking at source freshness, and it was something to do with how we were getting the data that it just didn't really work out as a viable solution. But again, yeah, a really good alternative.
Just a quick thought. I see through the dbt macros, you essentially recreated the tasks that you otherwise would have created through Snowside. You already mentioned that the downside of having Snowside-based deployment. I understand that.
Yeah.
But because you can actually access a stream directly from dbt, have you give it a thought of creating dbt jobs, doing the task equivalent of what you do in Snowflake? Because you can still create a models, because stream is, you can consider the stream as your source as opposed to the actual table. Because it will always give you the incremental, assuming the incremental is what you are looking for.
Yeah, that's
not the entire population, and then use the stream itself as the source within the dbt models, and then have the dbt job do the job, do the task which you otherwise would have done through.
Yeah, that's a really interesting concept. I actually haven't thought about that. In our specific case, we don't necessarily care about the data in the stream, just that the stream itself has data. But I've never actually explored using a stream as a source, but it seems like an interesting approach to building something incrementally. Yeah. You can? Oh, okay, that's really cool. Yeah, I had no idea. Yeah. Yeah. Okay. Oh, that's really cool. I didn't know that. Yeah, and then presumably you have a post hook that increments, that clears the stream out. Yeah. Okay. Right. Okay, that's really cool. I'd never thought about that. Thanks for sharing.
So first, thank you for sharing this knowledge. This is, I think, the coolest thing that I learned at Coalesce this year. So just
thank
cheers
you.
and
I appreciate
congrats on that. Yeah.
Thank you.
My question is on the schedule. So in the sample code, you showed like a 15-minute schedule, and then live. Did you just create a different task that had like a 30-second schedule or something? So that's like part one of the question.
Yeah.
And then part two is, have you ever considered serverless tasks which don't consume warehouse, or
yes.
They consume warehouse credits differently?
Yeah, so actually, I'll answer both of that. The actual task macro that we have, you can specify what schedule you want. So I deployed it using a 1 minute because I was terrified that this wouldn't work in the demo. And then, yes, I would recommend using serverless tasks over specifying a warehouse itself. But for the sake of the example, I thought it would just be simpler to not get into serverless and just say use a warehouse. But use serverless. Don't use a warehouse. Yeah. Word on the street is serverless is cheaper.
I think we have have time for one more.
One more, I think, in the back. And I'll hang around and happy to chat also.
Hi. Yeah, thanks again for the talk. I was just curious if you have any other Snowflake work streams that you have in mind that you're considering automating in this way.
Yeah, so we actually have been toying around with using this to deploy some ML models. So we had a situation where essentially, I guess let me back up for a sec. I think one of the key things here that I maybe didn't emphasize enough is that if you tweak the permissions on your dbt service account, you can essentially use dbt Cloud to deploy any resource that you want into Snowflake. I think that's a really powerful tool to take advantage of. But so in our specific case, Snowflake has been releasing these really interesting ML model features. And we've been struggling to figure out how we can essentially retrain them when we get new data while sort of fitting into the work stream of dbt. And it's a little clunky. We've been trying things out. But essentially, we've settled on something similar where we have these macros that produce sort of like generic models that we can, like resource macros that create models that you can then specify parameters for. And then what we've done is we've actually used streams to training of the models to the sort of input data. So that's something that we've been exploring. I think hopefully maybe next year we get to talk about it. It'll be a little bit more fleshed out. But yes, that's one example.
Very cool. Thanks. Well, I'll be looking forward to that demo next year.
Yeah, thank you all.